Yeah, hi all. Welcome to the today's class. Today we are going to see collections. We're going to talk. We're going to see some examples, and we're going to talk more about the collections and what is a collection and what type of interfaces are available in a collection and what are the difference between them. And we'll be seeing on which scenario which collection we are going to use. So we'll be talk about them a little more. And do you guys have any doubt from yesterday's session? I would like to answer them, and I would like to uh, go for the collections. Yeah, if you guys get any doubt, you guys raise there and there only, and don't wait for end of the session or don't wait for ask later point of time. So because that time you may forget or I may look end of the session or something. I may rest. I may in hurry mode. So better whenever you get a doubt, you guys better ask the then and there. It'll help us to you can clarify your doubt and you can concentrate other thing. I always encourage that. Okay, let's start collections. And before that, let me start my. Okay, what is a collection? Why we need a collections? Okay, a collection is a group of objects and they are represented as a single unit or single entity. If you want to play around with a group of objects and where you want to do some kind of operations in the group of objects, and that will treat it as a single entity. I can say a single reference for the multiple objects. As we know that in Java, everything is an object except the primitive data types. Even we have a alternative for primitive data types. Those are called wrapper classes. And if you want to play around these objects, if you want to play around these objects, we should have a one frame. We should have a one type of framework. That framework is called collection framework. Collection is a group of objects where we will do up some basic operations where you want to add, modify, delete, traversing through or such, and we'll treat it as a single entity. Collection is the it's kind of data structure I can say, and what kind of data you're going to store and what kind of data you're going to play around or what kind of objects playing around. Collections is a class. Collections is a class. It's a utility class. Collections. It's a capital C. So collections is a class which has some utility methods where you can see you can add, remove, search, sort, and you can make some collection to converting one collection to other collection, converting your array to collection, right? So collections is a utility class which has the public static methods, and you don't need to create object for the collections class. You can directly access collections dot sort, collections dot as a list, collections dot synchronize. So it's a class, it's a utility class where it will provide a set of methods to play around the objects. And with a small c, collection, it's an interface. It is a top level interface, and which is giving you, or there are some other interfaces which are extended or extended from these collections. Those are like list, set, queue. We'll be seeing list and set, and you may thinking about map, why the map is not common to like a collection. Map is a separate interface. We'll talk about these three. And queue, when you understand these three, queue automatically will get, we can easily understand what is a queue. Clear guys about this? right? It seems that someone is okay. Now let's see our architecture of the collection. Then we'll go and talk each other. As we know, object is the top level class for every all the classes in Java, but we will see from collections. Collection. You have a list interface, you have a set interface, and you have a queue interface. These are interfaces. This is some high level architecture or a high level uh, hierarchy of our collection. And this list has been implemented by a set of classes. And let me take in this way. It has been taken a set of classes. Those are array list, vector, linked list, and the set has set, linked has set, and it has a tree set. And queue has a priority queue, and here it will come set in here it will come in the stack and all priority queue. Anyway, we are not going to talk about this. We will see majorly what is the set and what is the list and what is the functionality of these two, and we'll be seeing them in detail. Clear, guys? Okay, let's talk about the list. Let's talk about the list. What is the list interface? What are the functionality it is giving? And what is the array list and what is a vector and what is a linked list? We will be seeing them first and then we'll move to the set. Clear about this architecture? I mean this hierarchy. Let's talk about list. Before getting into the list, I would like to make you understand using collections, we'll be doing some basic operations with the objects. Like it can be a collection of employees, it can be a collection of students, or it can be a collection of persons, or it can be a collection of departments. It's a collection of objects. We're talking about collection of objects, and we'll be representing as a single, we'll be representing as a single entity or we'll taking the group of objects and we're representing them as a single entity. We're keeping them as into a single entity, right? Let's take an array, an example. Array is a linear list of elements. Array is a linear list of elements which contains same kind of data. I can say it's a homogeneous. It's a homogeneous data type or homogeneous type because in the array you can have only same type of data. We cannot keep character. If I define an integer array, I cannot keep a character, I cannot keep an integer, I cannot keep double, I cannot keep different type of data into the array. But it is a collection of integers. It is a collection of float. If you define the float array, it is a collection of float. If it is a defined string array, it's a collection of strings. It is a collection of. It is not a single one. It's a collection of. But we are keeping it as a single entity. And what are the operations we can do? We can add an element, we can remove an element, we can traverse through elements, we can search an element, right? The same way, by using collections, we can add an object, we can remove an object, and we can find. That means it's like a searching an object, or we can iterate through. We can go one after one. We can iterate through objects, right? I mean, why we iterate through each object? To look at each object, iterating through each object and looking at them. Clear, guys? And before architecture, I didn't show the map. It doesn't mean that map I'm not going to cover. I'll cover the map, but map will not come under the collection. Map is not extended the collection interface. So that is the reason I didn't show there. We will talk about that map as well. Okay, let's see a list. Clear, guys? What are the operations we are going to do with the collection framework? What are the operations we are going to do with the collection framework? We can add an object, we can remove an object, we can search an object, and we can traverse through each object. We will play around the multiple objects. It can be a employee object, it can be a student object, it can be a department objects, it can be some XYZ objects. Okay? List. What is a list? What are the functionalities it will give, and what is the features of the list? How it different from other data structure? What is a list data structure? First of all, we try to understand what is a list data structure. List, and before getting into the list, I just want to give an idea how the list will looks like. We might have come across arrays in C, C++, some other languages. Array. What is array? What is array? Array is a linear list of elements and we store the same type of data, right? And it stores the same type of data. If I define integer, it will store integer. If I define float, it will store float. If I define character, it store the characters. If I define strings, it will store the characters. And it has been identified, or it will traverse, or we will access the data from the arrays by using indexes, positions, I can say, right? You guys are clear about this? We might have come across the arrays. And if you define the size as a 5, it is a fixed, it cannot be changed. If you define the size as a 5, or if you define the size as 6 or 10, it is fixed, it cannot change automatically, right? And we will see what is advantages of a list, how this problem, or this how this limitation will overcome by collections. Okay, list is an interface. List is an interface. The data structure looks like, we're talking about objects, right? The data structure looks like, we'll be having a different kind of objects, and it will be representing by a position. Let's say 0, 1, 2, 3, and 4. It can be any object. You can say here Java, you can say here J2EE, I can say here Hadoop, I can say HDFS, I can say MapReduce. It's a it no need to be a linear list. It's no need to be a sequential. We will see in one case this is sequential, and one case it's not sequential. And some of the classes who are defining, we are extending from the who are implementing the list interface, they'll follow the sequence. And some of the classes who are implementing the list, they'll not follow the sequence. We'll see that. But it can be accessed through index. If I want to access Java, I can say that get of 0. I can say the list I'm representing like this, and if I want to get the list, get of 0. This get, and what is this get method, what is the add method, and all will come from the utility class. We saw that, right? Collections class. From the collections class, these methods are available. Or from list, it has its own some methods where we can make use of them. We will see them in detail. List list will maintain index. The first point is list will maintain indexing. It is indexed base. It is indexed base. And your list will allow the duplicates. Your list will allow the duplicates. Let's assume that I have one more object. This is fifth position. I can have a HDFS here. It will allow the duplicates. And these points are very much important, guys. Please note down. This is a type of data structure. List type of data structure is a indexed based data structure, and it allow duplicates. It allow duplicates. It allow null. I can have one more object here in the sixth position, which is a null, and it maintains whatever the order we insert. Whatever the order we insert. Let's say it is not sorted. It is not sorted, but it will maintain the order. It will maintain the order what you have inserted. It is like insertion order. Insertion order. Let's say first you have entered the Java, JTE, Hadoop, HDFS, MR, HDFS, and null. It will, while you are iterating through, or while you are printing, while you are displaying this object, it will come in the same order. Whatever the order you insert, it will come in the same. Why it's come in the same order? Because it's of index. Why it is maintaining the order? Because of index, right? The first position I have, 0th position I have kept Java. First position I have kept J2E, because it's a position based. It is a position based. That is the reason our list is providing a feature order, insertion order. It is allowing null values and is allowing duplicates. It is indexed based, and it also maintain the order which you insert. It's not like a random, because it is a position based. The first position comes someone and second position comes someone. It should be same order, same order. It is not like random, right? And the last point, and not only this, and all the collections will allow this point. It can have any type of data, any type of data. Let's say in the seventh position I want integer. I can store. I can store. In eighth position I want to store a character. I can store. Because in a collections everything treated as an object. Everything treated as an object. So it will allow. Clear, guys, about the list? If you guys have any doubt, please ask me, and I'll explain what is a collection list. Then we'll move. There are some setup classes who implemented the list interface. We will see those classes. I hope everyone is clear. And I'm just repeating. List is indexed based, and it allows the duplicates. It allows the null value. It maintains the order. Why it is maintaining the order? Because of it is index based. It is a position based, and it can have any type of data. Why it can have any type of data? Collection framework is meant for the play around the objects. So everything, whatever you insert or whatever you keep the data in the collections, that will treat as an object. Okay, and let's say you don't want to store other type of data in this. You don't want to store other type of data in the your list or set or your map. So there are other concept called generics. We will see generic. The generic means it will allow only the same type of data. Type safety. It will gives you type safety. We will see that generic concept later point of time. If you specify my list has to take only strings, it will take only strings. It will not allow any other types. If you specify my list has to, or my set or my map has to take integer, it will take only integer. It is like templates in our C++. I think C also templates are there. I didn't remember. Templates. It's like a templates. I think C is, it has a templates as template concept is there in C. I hope. Yeah. Clear? Let's go ahead and see what are the classes. What are the classes has implemented the list interface. In which real-time scenario it will be useful mainly. Very good question, Chandu. And you have a set of objects are coming on, or you are maintaining some set of objects, or you are maintaining some set of employees objects, and you don't worry about the duplication. Let it come any duplicate. Let it come the employee come any number of places. I don't mind. And you also concern about the index, first position, second position. You are concerned about the position, and that kind of scenarios will go with a list. Clear? Or you are getting a set of objects. You are taking, let's take a MapReduce program, and you are taking a list. You are taking set of words, or you are taking set of events you are handling. You are handling with a set of events, and you don't mind. You don't worry about any type of event it can be. Event is like one action. Let's assume that you have logged into the e-commerce application. Your login event, your logout event. You have searched event. You have seen the product event, and you have inquired about the product. That is one event. You log out, and you have moved to some other pages. You have compared two products. You have given one comment. All are different kind of events, or different kind of actions, I can say. Each action we can treat as an event, and you can log in multiple times, and you want to see how many times he has logged in. That scenario is the login event is the same, but you want the duplication. Let it come the duplication. That kind of scenarios will go with a list interface. That kind of scenario will go with a list where you don't mind about the duplication, where you want to see index based, and where you won't worry about the duplication, will go with the list interface. And actually we'll not directly use the list interface. There are some classes where will the list interface has been implemented, those classes will use. Okay, and let's see what are the classes are implemented a list interface. The classes are array list, vector, and our favorite one, linked list. We might have seen the linked list in the C++. Linked list data structure, we might have seen this in C++ or C also. Okay, well, let's go and see a detail about each and every class, what are the APIs it provides and what are the methods it's providing, and how it is different, and we will see, and we will execute an example, then we'll move to next other interface. Clear, guys? Okay, let's go to let's see on each class. Let's see about a array list. Array list is a class. Array list is a class which is implemented list interface. If it is anyone is implemented the list interface, they will get the same features. They will get the same features, right? See, the list is a top level parent. He has some features. The kids also will get the same features. So those features are like, it is index base. Yes, this guy also index base. It is indexed base. It will also allow null. It also allow it's also allow duplicates. It's it's also allow any type of data. The implements from parent. Yes, these behaviors are came from the parent. These are all features. This the same features will come for array list. It will come same features will come for the vector, and the same features will come for the linked list as well. And what is the specialty of a linked list? Sorry, array list. This array list is a growable array. Growable array. I can say if you take your array list, if you take your array, you have fixed the size of 10. We cannot insert the 11th element. When you try to insert the 11th element, it will throw a exception out of array size out of a bound exception. And you cannot change the size. You cannot change once you have declared, and you cannot change the size of array. Where you have a requirement, as soon as you don't know how many elements will come, you don't know in the before only, you don't know how many elements will come, you just want to keep inserting the elements. It has to grow dynamically. It has to grow dynamically. You'll go with array list along with these features. If it has to be a index base, and it has to allow the null, and it has to allow duplicates, and it has to grow automatically, that time we'll go with array list. We'll go with array list. Let's assume that initially I won't specify any size, and I'm keep inserting the elements. It will keep grow. And also, it will keep, as I said, it's keep grows. And also it gives one more feature called fast iteration. Fast iteration. Iteration means going forward, moving. Next element, you can retrieve each and every element, traversing through. And you want to get some element, you can get it directly by specifying the position. And also, it has been implemented. Why it is a fast iteration? Why it is a fast iteration or retrieving? Because your array list has implemented array list has implemented array list has implemented random access. Random access. This is an interface. It is a marker interface. Marker interface. Do you guys know what is a marker interface? Do you guys know what is a marker interface? Marker interface is an interface. Marker interface is an interface which doesn't have any method, any variables. It is an empty interface. Let's see. Interface. Marker interface. Demo. It will not contain anything. There won't be any statements. It's just an empty. Marker interface is an interface which doesn't have anything. It can be a variable, it can be a method. Nothing will happen in that. It's just an empty interface. Then you can ask me what is the use of it. The use of it, it will tell to the JVM, whoever implements it, it's indicate to the JVM saying that if these guys are implemented me, these guys are special feature compared to the other classes. This class has a special feature. What is that feature? So depends on the interface use. Depends on the interface use, that will be defined. Let's say you have used random access interface. You have used random access interface. When you say the random access interface, what will happen? It will tell to the JVM, boss, this array list guy has implemented me. This array list has implemented me. He has a special feature called where he can access randomly very fast. He can access things randomly very fast. Other classes cannot do that. Why? They don't have this interface. The specialty of this mark interface is that it will enable a flag in JVM. It will tell to the JVM saying that this guy has a special feature. This guy has a special feature. Like there are some examples like random access, serializable. There are some other examples like random. This one RMI, remote call procedures. Sorry guys. Remote call procedures, RMI. Okay, and clonable. There are some interface called clonable. When you say clonable, it will tell to the JVM saying that this guy has a feature called clonable. He can clone me. Others cannot clone directly. When you implement the clonable interface, it will tell that this class has a special feature. Clear, guys? Clear about the marker interface? This also gives the same features which is given by your list. It allow index and it is index based and it allow the nulls and it allow the duplicates and it's a global array and it is meant for fast iteration. Why? Because it has been implemented random access interface. Okay, and let's assume that you have a more insertions. You have a more insertion and deletions from the array list. You want to do more insertions and deletions, then this class is not meant for that. This class is meant for iterating or retrieving the elements. If you're doing more iterations and like more inserting or more deleting in our collection, we have a special collection for that. We don't go with this because it will give a less performance in that case. If you have a more deletions, if you have a more insertion in the collection, the collection is ready with you and you're trying to do more insertions and more deletions, lot of operations you are doing with that collection, then it is not preferable. Then we can go with some other collection class. What is that collection class? That collection class is a linked list. For the more deletions, more insertions, we can go with linked list. We can go with a linked list. For where you have a more iterations, more traversing through, or more retrieving, we can go with the array list. Clear, guys? And also other feature which is covered by your list feature itself is it will maintain the order, the same order which is inserting order. Because all the people, whoever implements the list, all people will get the same functionalities. I no need to specify explicitly. Those all the same features will come by default order. This above feature what we have discussed in a list under the list, the same will allow for all the guys, but the special features are like it's a global array and it's meant for the fast iteration and it is not synchronized. It is not synchronized. We have seen what is a synchronized yesterday and some other class. I hope we have seen synchronized. What is a synchronized? We have seen what is the other class. It is not thread safe. It is not thread safe. Multiple threads can access at a time. Okay, we have morely discussed about the synchronization on the last class. I mean last to last class. These are the special features of the list. Above features are common to whoever implemented list interfaces. List interface. And these are the special feature for your array list. Clear, guys? Are you guys clear about this? One thing, we need more retrieving and deletions and update. We can use both array list and linked list. Array list and linked list both are different, Chandu. Let's assume that how you're asking such a way that I have a more insertions and deletions and retrieves, and you're telling that let's say I equal to 10 and j equal to 10, and these both are referring different, right? I is referring different and j is referring different. If you want, let's say how we'll create object for the array list, we'll see that. Okay, let's assume that you have created array list al equal to new array list, and you have given some elements on this, and you have given linked list ll, and you have created some new object here. And how can you use both? How can you use both at a time? You can use any one of that, right? See, more retrievings and more deletions and updates, it depends on the requirement in the single. If you have a in a if you it's all three operations. If you are going to do in a single object, like all three operations you are going to do in the single data structure, we have to choose which one is preferable. You can see that which deletion and insertions are more operations, or retrieving is more operations, which is more important. According to that, we can choose whether I have to go with the array list or whether I have to go with the linked list. If you have a more operations like retrieving or getting the traversing through, or we'll go with array list. It doesn't mean that array list will not allow the insertions and deletions. It is a slow comparatively, the performance less is comparatively linked list. When you have only insertion and deletions, only have insertion and deletions, your linked list faster comparatively array list. Your array list also will support insertion, deletions, traversing, such and everything will support by array list. The same operations are also will support by your linked list, but performance only will concentrate on performance. If you have a more operations are like inserting more and deleting more, then we'll prefer go to linked list. It's a depends, Chandu. It is not like a Hadoop. Hadoop uses only one. Hadoop is not no common use case for everyone, right? Some guys are playing some other use cases. Some guys are playing some other use cases. Depends on the use case, they will go. If let's take my example, I use both. Different kinds of situations. Different type of situations, I'll use both. Where I'll maintain only traversing, or only I'm inserting, or only I'm retrieving the data, I'll go with array list. At some other class, I'm going to see more operations on more deletions, more retrieve, more insertions. I'll going to do. I'll use the linked list. So it depends on the use case. You will go with which class you are using. It is not like a fixed in Hadoop. Everyone should use only array list, or everyone should use only linked list, or everyone should use only some XYZ class. It is not like it is not a fixed. Depends on the use case. You're talking about data, the structure of data. You're talking about structure of the data of HDFS. HDFS is read many, write once. That's correct. That is the way the data is stored. You might have retrieving many times, right? The data is not storing in arrays. The data is storing in low HDFS file system. We're not talking about the file system here. Let's take, you have a one file, okay, and in that file you have so many, you have in that so many words, right? You want to maintain, you want to maintain all the words in array list, or you want to maintain same uh, how can I say that, you want to maintain that the length is 3, okay, whoever has the length is 3, all keep in one place. Whoever length is 3, the word length is 3, you want to keep in one place, and you don't worry about the duplication can possible, then we'll go with array list. Or you want to, if it's only insertion and deletion, you can go with the linked list. You understand that what I'm trying to explain? Let me see, let me explain you here. Let me take a new, you have a one file, text file, which has so many words. Let's say you have a three-letter word. I'll take the direct numbers, not the word. Okay, let me take a words itself. Say Java, Hadoop, J2E, Pick, Hive, MR, Apache, Cloudera, something like that. There are some words, and what your use case is that if the length is 3, all should go in this array. If length is 4, it should go in this array. I don't worry about I don't worry about the duplication. Then what you will do, you'll find whoever has the 3, pick, and you'll find someone else, MR1 or something. Just assume that MR1 will come MR1. There may be some other place MR1 comes. There may be some other place where pick can come. It's just an instructions. This kind of scenario, I'll go with a linked list. And let's assume that after creating a linked list, you are trying to do more operations on this removing or deleting or this kind of operations. I'll go with the linked list. Let's assume that you have only after creating a linked list, you want to only have there is a set is ready, the list is ready. You just want to try to retrieve the elements. You're traversing through in a while loop or somewhere. You're traversing with each element. I'll go with array list. Clear, Chandu? So it depends on the use case. Depends on the use case whether you'll use array list or whether you use something else or whether you use a different. Okay, now here you are not worrying about the duplicate, but you don't want the duplicates in this. There is a separate data structure for it. We'll use that data structure. Clear, Chandu? Chandu, I think you have still have some doubt. You can switch on the mic and you can talk, Chandu, if you're taking time to type. Hello.
No, Virak cleared. Roads.
Sorry.
No, Virak cleared.
Okay, you understood. Okay, fine.
Understood.
Yeah, fine. So let's see. That is a one class. We'll see example for that class. Before going to that example, I just want to give another class which is implemented the list interface. I'll show you the difference between these two. Other class is vector. This guy also implemented. This guy also implemented a list interface. Then what is the difference between your array list and vector? How it is different from the array list? The, there is no big difference between array list and vector. Both are similar. Both the functionality is the same, and both will give the same features. Except this is synchronized. It is synchronized. It is synchronized. All the methods in vector class are synchronized methods. If you guys remember in last class we have seen string buffer and string builder. String buffer has all synchronized methods. String builder has the same methods but not synchronized. That is the only difference between your vector and array list. In vector, all the methods are synchronized. By default, they are synchronized. It's called as a thread safety. Why all the methods are synchronized? I mean, if you have something, one collection of objects, you don't want to access by multiple threads at a time, and you want something has to be referred by some object which will contain the multiple objects. Where you want to make a thread safety, we'll go with the vector. When we'll go for it, we really bother about multiple threads are accessing my collection, and they may change my data, or it may corrupt my data. that that time that time we'll use the thread safety. That time we'll go for the vector. That time we'll use the synchronized vector. Why? Because let's assume that you have a set of objects, and if multiple objects are trying to modify, and they may end up the wrong results. One guy, we have seen one use case last class, and they may end up with the wrong results, and they may come up with some wrong results. Ideally, we don't want to do that. We don't want to uh, get into that situation. We'll go with a vector. And comparatively array list, it will give the less performance because all methods are synchronized. Only one thread at a time can access, but vector can access multiple threads. And depends on which scenario you have to go with a vector, and which scenario you want to go with a array list. Let's assume that I'll just give a small example. Let's assume that there is a value. Okay, none of the thread will change this value. They'll just access it. They'll just see that according to that value, they will act accordingly. They cannot go ahead and change it ideally. They will not change it. And this kind of scenarios, I'll go with array list. And this thread may change the value. So T1, T2, T3, T4, T5, T6. This thread may change the values. That kind of situation, that kind of use case will go with the synchronized. That will go with a vector. Where multiple thread can attack and they may change the value, that kind of scenarios will go with a vector. Because it's a synchronized, only one thread can access at a time. And also, as I said, it's completely similar to array list, right? This guy also implemented random access. As I said, yeah, it's completely a duplication of your array list, but it all the methods are synchronized. Like your string buffer and string buffer, there is no difference between these two classes. The only difference is synchronized. The same way, here your array list and vectors are both are similar, and your vector is a legacy system. It is a legacy system. It was there before 1.2 as well, and 1.2 1.2 onwards. It is 1.2 before 1.2 also. It was there. Vector class was there, and it was not part of collections that those days, and it became a part of collections later. What are the classes they have introduced early days in 1.2, 1.4, before 1.4 and all? Those classes are by default synchronized because they are concerned about the thread safety. Later, they have improved in the later versions, and they brought the alternative classes for them. The same way, vector and hash table, we'll see more about it. Hash table is these both are a legacy system and legacy classes which were there and before 1.2 onwards. Before 1.2 also. These are there from 1.2, 1.3, 1.4. And later, we Java came up, community came up with a collection framework. Under that, we have array list. Some they have modified something. We don't need to know about it. But clear, guys, about the vector. If you guys clear, I'll just go ahead and show you one example for array list and vector, and linked list we'll talk about after that. Okay, let's move to an example. Okay, before that, this is class level array list. Let me take you a simple array list. Simple one. Yeah. Okay. I have created array list. Array list equal to new array list. I have specified the size of it, and I'm printing the size of it, and ensure capacity. How much capacity it can. It will ensure us. So it will ensure us this much capacity can increase, and we can add the elements. If you see here, I have added element which is a string. Here I have added a integer type. Here I have added a character type. Here I have added a float type. Here I have added a double and against a character, right? And we'll see this one later point of time. We don't worry about it. And as I said, I can add duplicates. Let's say I'll add duplicate. I'll add a duplicate. That is 1 lakh. Can add the duplicate values. As I said, it will allow null values as well. Okay, it will allow the null values as well. We'll just print them. Okay, you just forget about these things. You just see here. If you want to see what are the methods are available in this, you just click dot and you see add. You can add them by specific position. We can add all. You already have on list. You can go ahead and add with that list. Let's say add all. Already have another one list. I can give that list. Already you have one list before that list also. You can go ahead and add. I mean, I have here. I'm adding the same list. I just want to show add. You have so many methods: clear, clone, contains all. You want to check whether it contains or not. You want to check whether this value contains this array list or not. You can go with the contains method. Ensure capacity. You can how much in the when it's growing, how much you want to grow. How let's say your size is fixed as a 12, and after 13th element when it's insert, how much you want to increase the capacity by default. And you have a get. When you want to retrieve a specific element, you want to get the element of first position, you can say get of 0 or get of 1. It will give you that position. And is empty, you can check whether it's empty, it has a values or not. And you can iterate through by using iterator. We'll see that each element you can iterate through, and we'll talk about the list iterator later point of time. It's not required now. You can remove the elements, you can remove all elements. You can you can set some elements. You can get the size of it. You can do the sublist. You can get the sublist from where to where you want. You can trim the size. Others are default methods like wait and wait for notify. All of those are other methods. Clear? Now before you just try to print. I'm just printing. Here I no need to mention dot toString and all. Because the array list class itself is as a toString. If you want to see array list class, you can go just click here, go to class, array list class, and go. You just see what it has been implemented. This is the source code. You guys may not able to see the source code because you guys don't have the decompiler. There will be one more tool called JAD, Java decompiler, in your Eclipse setup it might not have, and I'll give the link how to set up it. Okay, if we see array list, it has been extended the a class called abstract list. We no need to worry about it. I'll come to that point. But it's implemented the list interface. It's implemented the random access, and it implemented the clonable, and it implemented the serializable. Are you guys able to see this? It implemented random access interface. This is source code, guys. This is source code, means how the what Java is provided. It has a random access. As I said, because of the random access, it has a faster access. It has a clonable. You can do a clone. You already have an array list. You can clone it. You can get the clone, in the sense you can create one more object from the existing object. Same object. It's kind of creating a duplicate object. And serializable. We'll see serializable in detail in one session. Before going to threads, I'll give the serializable, because the we need to understand what is the serializable and deserializable for the map reduce also. I'll take one special class for that, serialization and deserialization and externalization. Okay, these are the interfaces by default it has been implemented. If you see, it has a default capacity. There are some other elements, we don't need to worry about them, but you have a size, you can get the size, and you have one constructor. How you'll constructor can be the initial size. If you want, you can create initial size. Okay, and you have a empty constructor where you can create empty array list. You have a other array list constructor where you can create an exist, already you have one list, you can create one more list on top of it. Let's see how it will be. You have already one array list. You have already one array list. Let's assume that this array list has a 100 elements, added so many elements, like that 100 elements are there, and you are creating array list 2. You can directly pass this existing array list. You can directly pass the existing array list and create. This array list will contain all these 100 elements. It will become a new array list. This is other way of creating array list. Or if you don't want to do here, if you don't want to do through constructor, what you can do, array list dot add all elements of array, existing array. That there are so many operations. You guys try all the operations. There are so many operations we can do array list. You can add all. We can do sub list. We can find contains, whether it contains or not. We can check whether we can check whether it is empty or not empty. We can get the size of it, or we can get the capacity of it. We can insert it. There are so many operations. There are so many operations we have to do. I request you guys to do it. Instead of I'm telling each and every operation, you guys try this. And trim to size, you can trim if there is empty spaces, and it can be trim means reducing. There is some empty spaces unnecessarily occupied. There is some empty spaces unnecessarily occupied. Let's see. Let's see, the memory, it has been occupied like this, and you have values here, and but you don't have values here. These are empty. These are empty. Here you have some values, but these are empty. So when you say trim, the size will be reduced to here, and this will be deleted. There is no use of it, right? I'll explain some of the methods. Rest you guys try it. You guys do a hands-on. I'll explain the method, some of the methods. Ensure capacity. You can give the capacity, how much capacity initial it is. See here it's clearly specified. Increase the capacity of this array list instance if necessary, to ensure that it can hold at least a number of elements specified by the minimum capacity. There are so many methods available along with this. It will dynamically grows. We no need to say anything. You just insert the 12th or 13th element. It will dynamically grow automatically. You can get the size by using the size dot size, and you can check whether it's empty or not by using dot is empty. Array list dot is empty. It will tell you that whether it's empty or not. If your array list is empty, it will says it is empty. If it is not empty, it will says it not it will says that it is not empty. It means it will return true or false. And it has a method called contains, and you have to pass some element. Let's assume that you have 100 students. All the students, different kind of students are there. You want to check whether Veera is there in that students, that list. You can say students dot contains Veera. So you'll pass the Veera object there, and it will check whether if Veera is there in that list, it will return true. If Veera is not there in that list, it will return false. You have index of the same as how the index of will work in normal cases. Last index, clone. Clone means you can get the same kind of object. Cloning, we might have heard about the cloning. See here, it's just taking a copy of existing voila. It's just doing a copy. Clone means you just get copy of it. To array, you can convert your array list to array list to array, or your array list to array to a list. And you have a get, where you pass the position, it will return the value. Where you have a set, you can set by specifying the position. You have a add method where you can simply add at the last position. You have a add method where you can add into the specific position, and you can remove also there, and fast remove, clear. There are set of methods available. Add all. There are so many methods are available. As I suggested earlier, you guys go to Java 7 documentation API. Here, click on this link. It will list out all. You just say frames, and you select. This is the documentation for Java. Guys, this is very much important. This is documentation for Java, and you select which package you're talking. These collections are came from the util package. Earlier we were using only lang package. This lang package we were using before, and we are going to use util package, util package. When you click on the util package, it will list out the what are the interfaces are there in that list. I mean that package. What are the classes are there in that package, right? And some exception classes and error classes, it will list out enums and all. What are the that belongs to that package. Okay, let's see, we are talking about array list. This is we are talking about array list. When you click on the array list, it will give some information about the array list, and it will show you some constructors. What are the what type of constructors it has. Empty constructor, it means a default constructor, and parameter constructors. And it has the methods. This is another one I want to bring. Here you find all the methods. Add all, different kind of, in specifying the position. It's a method overloading, right? Ideally it's a method overloading. Clear, clone, contains, ensure capacity, get, index of, is empty, iterator. What is iterator meant for? You can iterate through each element. Last index, list iterator. We'll see that list iterator. Actually, both the directions we can iterate here. I don't want to I don't want to confuse you guys. See, normal iterator will go with the forward direction. When you want to come the backward direction also, we can go with a list iterator. We'll see that in detail. Remove all, retain, set, size, right? Clear, guys? These are a specific methods. I mean, these are some methods for your array list class. Any doubts? I'm expecting one question from you guys, but you guys didn't ask me that question. The question is that what is the difference between add and set? We have a same purpose. Add is doing the same and set is doing the same. What is the difference between these two? Add will add the element and it will keep the, let's say I have specified add of 10th position. I want to add, okay, let me use my board. I have array list. I'm going to change, if I add of 2 comma, I'll just say 5 number. And what it will do, in the position of 2 it will add the 5 and it will move, this will move 3 and this will become 4. But when I say set of 2 comma 5, it will remove existing value and it will keep that value. In add it will adjust the positions, in the set it will replace it. Clear guys? Are you guys clear? Yeah, that is the difference between those. So please go through these methods and also try to look at this documentation every time. The documentation will give more information when you are going to implement something. It will give more information. It will be having a each and every explanation for each method, what the method will do, how to use it. Okay, and if you guys want it, I'll share this link. I pinged it here. You guys can access this link. Clear? Let's go and see our example yesterday. You just, these things I'll just bring to you now only, but you just see, this is our before this line, right? Before this line we want to see. Okay, array list size. Initially I have created with a 12, the size as 12. While creating my array list I have given size. You can give a size or you cannot give a size. You can create it like we have seen, right? Multiple constructors, empty constructor with the parameter constructors and with array list constructor, three constructors we have seen, right? And if you see, I have used parameter constructor which I'm passing the size. Even though I specified the size, when I didn't insert any element, I just checked what is the size of it. It is a size 0. Even though we specify the size and we try to print it, what you try to get the size of it, it will telling that it is 0 because it's not occupied any memory space. But it can take a size as 12, but it's not occupied any memory space. That is the reason 0. And after that, I have added one element called Kusuma. Okay, and I try to print the size of it, then its printed size is 1 because one element is occupied. Your array list, how many elements are there, that much space only it will be occupied. It's not like normal array list, normal array, the normal array will occupy the whole space. Then it will start insert the values. And I have added 1000, you see here. 1000, I have added 1000, I have a character, I have added some no float value, I have added some long value, I have added some characters, null and duplicates. Again, why it is printing twice? Because I have used add all. If you see line number 33, I have used add all. While add also I have given the same elements. That is the reason it's given the duplicates. Clear guys? Let's go to our next statements. Here what I have done, I have taken, I don't want the different type of elements in my array list. Now in the real time we never do that. We always do with a specific type. We in a real time will go with a specific type. Will not use the all the types like integer, float, mixed up all the types. In the real time, most of the real times we'll use with a specific type. Let's assume that my list contain only the names. My list should contain only names, the first name or second name, whatever it is. My list should contain only the names. So I'll specify like this. You can give array list also here. This is the other way. This is the parent child. This list is a parent of array list, right? Your parent can hold your parent can hold child objects. If you remember our last class, inheritance class, our parent can hold child objects. So I'm creating object by referring my child parent. Okay, list string of string. It means that I want to only strings in it. And your array list, your object name, and new array list of string. You have to specify this way. Please remember this is the syntax for it. Anyway, I'll share this program to you guys. And I'm adding the only elements. If I try to add a number, let's see what it is telling. If I try to add a number, let's see what it will tell. The method add, position and number is type list of string type, is not applicable for argument int. It will not applicable for different data type because I have specified it. I want only strings. I don't want other type. Clear, guys? And when you go ahead and print these values, it will start print. You can give null, and you can add all array list too. You can print these values and you can clone it. See, I have seen al, okay, and see here array list is retain all. It means that is your al contains all the elements in al2. Yes, it has true. It return true. It retains all the elements. And next, you just printed the array list 2. Line number 55 I'm talking about. You just printed all the array list elements. Yes, I have printed all the names are printed. Kusuma, Koneru, Java, servlet, JSP, or null, some values it has been printed. And the way vector we create, vector how to create, and iterator and all, you can try yourself. It's very simple. Iterator it equal to, okay, I'll do here only. Let me do myself. Now array list contains everything. Now array list contains these values also. The string values also array list contains. Iterator, sorry, not iterable, it's iterator. Iterator it equal to array list dot iterator. I can iterate through them while it dot has next and sysout iterating. What I can do, it dot iterator dot next. We have seen in last class with the string tokenizer we have seen, right? It has more elements. The same way here has next element. It will check whether the next element is there or not. Yes, it is there. And if it is there, and how to get it using the next method. There also we have a next method, right? The same way here also. And compile this code and you see, compile and run this code and see what is the results. So it is iterated. See here, iterating. First element I got it. Second element I got it. Third element I got it. So this is iterating by element. Why? Because these many elements are there. My array list contains those many. Clear, guys? And linked list also will create the same way. There is no big difference in the linked list. DQ also, and for the linked list, DQ also a parent. We'll see that in tomorrow's class. That's what I have planned, guys. If you do guys have any doubts, please go ahead and ask me. If you guys don't have any doubts, please no I mean, others can leave for the day. Whoever has a doubt, they can stay back.